we are going to today we are going to discuss about the generally about the forces. Okay. So first of
Okay.
all, we are going to discuss the resultant force. Resultant
Okay.
force. Okay. So what is resultant force? So resultant force is the sum of two or more than two forces acting on an object in straight line. It's fine. So this is called
Yes, sir.
resultant force. Like for
Okay.
example, we have the box. This is the box, have a mass m, and the force is acting on that box is that F1, and another force is acting on the box in the same direction, that is F2. Then the resultant force will be equal to F1 plus F2. It's fine.
Yes, sir.
Okay, there are two types of resultant forces. Remember that, okay? Just a minute. So, okay, so there are two types, two types of resultant forces. One is called balance forces. Do you know balance forces?
No, sir.
Okay, write it. When
The
the result,
force is that are in equilibrium.
yeah, that's good, that's good, that's good. When the resultant force acting on a body is zero, it's fine. So then,
Yes, sir. Okay.
uh, object will be at rest or in uniform motion. It's fine. So this is the
Yes, sir.
resultant force. Like, for example, this is a box and there are two forces equal on it. One force is on in this side. For example, this is F1, another force is on this side, that is F2. If the both forces are equal, then this box says this box is in equilibrium. It's fine. So means these forces will be the balance forces. Okay. The second type is unbalanced forces. Okay. So such type of forces in which resultant force is not zero. This is called unbalanced force. Okay. Unbalanced force. So, so during unbalanced force, unbalanced forces, the object accelerated. It's fine. So the main thing is that the object is accelerated. It's fine.
Yes, sir.
So remember that in balanced forces, the object is moving with the uniform velocity, uniform motion, or it is at rest. But when the forces are unbalanced, the object will be moving with the acceleration. Okay. So have you noted that? Yeah.
Yes.
Okay. So it is better to, I think, open the whiteboard. So I can write
Yes, sir.
more things. Okay. So 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 that's we are talking about in a straight line. Okay. That's we are talking about in a straight line. In a straight line. Okay. So as you know that F is equal to ma. You know that equation.
Yes, sir. Force equal to mass multiplied by acceleration.
And which is this equation? This is the Newton's second law. You know that.
Yes, sir. Newton per
Newton.
second.
No, no. This whole equation is called Newton's second law. You know
Ah,
that.
yes, sir. Okay.
Okay.
Yes, sir.
What's Newton's second law says? So kindly write the statement of Newton's second law that
Okay.
okay, because the statement is also very important. It is coming into the paper. When the force applied on an object that object accelerated. So, which is, so the acceleration is proportional. What? Directly proportional, okay? To the mass, to the force, and inversely proportional to the mass of an object. It's fine? Now, it's fine, Heather.
Yes, sir.
So it means A is proportional, directly proportional to force, and A is inversely proportional to mass. And when we rejoin that equation, that come out to be F is equal to ma. Okay. Remember that in this formula, this force, this force is unbalanced force. Okay. Unbalanced resultant force. Remember that. Okay. Why this force is unbalanced resultant force? Because the acceleration is there. The object is accelerated, so that's why this force is unbalanced resultant force. That's fine. So when mass is given to you 10 kg, acceleration is given to you 2 meter per second square. So the force is come out to be, what is the force? The force is come out to be, yeah, how much force you will get? Yeah, Heather.
Sir, 20. 20.
20, exactly. And that will be 20 Newton. That's fine.
Yes, sir.
So whenever the force becomes balance, A will be equal to 0, acceleration will be equal to 0, due to which F will be equal to 0. It's fine. Whenever the force will be balanced, acceleration will be equal to zero, due to which the force will become zero, means object moving with constant velocity. That's fine.
Yes, yes.
Or you can say uniform motion. In some papers, they will write word of uniform motion. It has the same meaning like a constant velocity. It's fine, okay? Now,
Okay.
this is we are talking about when the force is acting on a body in a straight line, okay? Now, have you noted this? Have you noted that?
Yes, sir. Yes.
Okay. Now if the force is applied perpendicularly, force change the direction. Now the second effect we are going to discuss, okay? Force can change the direction now. Okay. Now let's consider an example in which a body is moving in a circular motion. Now, for example, this is a uniform circle. We are considering uniform circle, okay? What is uniform circle? Do you know that?
Sir, I don't know.
Okay. I will tell you. So write it that this is a uniform circle, okay? I will explain it. So first of all, I make the diagram. For example, this is an object at position A. Now, what is uniform circle? The circle which have constant radius. That's fine. Do you know radius?
Yes. Yes, I know. I know.
So do you know radius?
Yes, I know.
So kindly write it. What will be the radius? Can you repeat for me?
Pi. Radius is pi.
No, beta, no.
Or
Radius, that is the
the
dis.
circumference of the circle.
No, beta, the distance
The
between,
distance from the center.
yeah,
Okay.
center and the surface point.
Okay.
Is fine.
Yes,
So
sir.
this
Yes.
is called radius. So here OA is the radius. Okay, this one is the radius. It's fine. Now
Yes.
the velocity direction will be here. This is the direction of velocity. It's fine.
Yes.
Velocity. So remember that, write it please. In circular motion, the velocity change its direction on every point. It's fine. So velocity changes its direction on every point. It's fine. The second point, in circular motion, the velocity is always perpendicular to the radius. What do you mean by perpendicular?
Sir, parallel.
No. What do you mean by perpendicular?
Means straight.
No, 90 degree, okay? If you see
Okay.
here
Okay.
that V and R making the 90 degree, okay? That is the meaning of
Okay.
perpendicular, okay? Now,
Okay.
in circular motion, The force acting on an object is always toward the center of a circle, okay? Center of the circle. It's fine? Yeah.
Yes, sir.
I'm going to rewrite again here. You can understand it. So how it is acting on the center of a circle, okay? So for example, this is our center and this is my radius. It's fine. Now, how the force is acting now? Now remember that the force is acting on toward that side. That is toward the center, okay? Anywhere in the circle is anywhere the object you place in the circle, okay? Anywhere, okay? So the always the force will be acting toward the center. It's fine. Have you understand it?
Yes, sir. Yes, I
So
understood.
anywhere you place the object in a circle, it will always, the force will be always acting toward the center. Okay. Now this force is centered force. This force is called centered force. Okay. In some book they have right, but in your syllabus that is not mentioned. That is centripetal force. Okay. Centripetal force. It is not mentioned in your syllabus. Okay.
Centripetal force.
Yeah, exactly. So the word of centripetal is not coming into your paper. Okay. They only call them center force. Okay. It's fine. It's fine.
Okay, sir.
Now this central force or this force depends upon three things. Number one, the force is proportional to mass. What do you mean by proportional to mass? If you increase the force, if you increase the mass, the force will also going to increase. It's fine. And if you decrease the mass, the force will also going to decrease. It's fine. Yeah, Heather, it's fine.
Yes, sir.
Okay. The second thing, the force is proportional to square of radius, to square of velocity, okay? To square of velocity. What do you mean by that? Means that if you increase the force, the velocity will going to increase. If you increase the velocity, the force will also going to increase. If you decrease the velocity, force will also going to decrease. That's fine.
Yes, sir.
Okay, the third point. The force is inversely proportional, inversely proportional to radius. So what do we mean by that? So it's mean that if you increase the radius, the force will going to decrease. Okay. If you decrease the radius, the force will going to increase. It's fine.
Yes, sir.
Okay. So this is something about the force which is change the direction. Now, have you noted these all points? Yeah.
Yes, sir.
Okay.
I have.
Okay. So now Heather, kindly rejoin again. So we will continue from here. Okay.
Okay, sir. No problem.